Hi, and welcome to this week's live session on YouTube from Impact Subsea. I'm Ben Grant, Managing Director of Impact Subsea. And this week, I'll be answering your questions live here on YouTube. Today, we're going to start things off by a brief overview of the ISD4000 Depth and Temperature Sensor, and then I'm going to answer some of the common questions that we get on this sensor. So to start things off, we have our ISD4000, which is a highly compact depth and temperature sensor with optional integrated attitude and heading reference system. The ISD4000 is available in titanium, as seen here, or we can also do the same sensor in the same housing, but in acetal material. So the sensor itself, you've got the connector end cap with the subcon connector as standard. And on the other end, you've got a plastic cover, which covers the raw pressure sensor and also the temperature sensor just in there. Both of these can be accessed by removing the black plastic cap. You can do that by the little clip there. You can get your finger in there and just prise the clip apart. The clip comes off, and then the protective end cap comes off and away. And you can then see and get access to the pressure sensor, which is ideal if you want to rinse it or clean it after a deployment. And you can also see the temperature sensor there. So again, it's ideal for getting access to that and just cleaning it out after use. It's very nice and quick and easy to reassemble. Just put the cap back on and take the clip and just open it out, and it snaps back into place just like that. So in terms of what the sensor actually measures, the pressure sensor will measure pressure to 0.01% of full scale accuracy. We can also calibrate it to 0.005% full scale if you need a very high level of accuracy and precision in your depth measurement. And the temperature sensor will measure temperature to 0.1 degree. We can optionally calibrate that to 0.01 degrees accuracy if you need exceptionally high accuracy temperature readings. Both the pressure and the temperature are very low latency readings. So any change in pressure will rapidly be progressed through to an output. It can output data anywhere up to 100 times a second. Likewise with the temperature sensor, that temperature sensor there, you can see there's a little stainless steel probe in there, and the probe itself is actually hollow. We hollow it out, and we slide the temperature sensor right into the middle of that probe. That ensures that all the readings are very low latency, as well as being very high accuracy. One question we sometimes get asked regarding the ISD4000 is which configuration of ISD4000 should I get for my application? For example, if you're working in 100 meters of water, what would be the best configuration to utilize? So in terms of the ISD4000, they all come in the same body. They look the same, but we offer them with a number of different pressure sensors. We offer 10, 30, 50, 100, 300, 400, and 600 bar sensors. So the idea or the ideal situation is to choose a sensor which is closest to your depth of deployment. In 100 meters of water, and you're never going to exceed 100 meters depth, then a 10 sensor is ideal. So that will give you 0.01% full scale accuracy. So you'll get about a 1 centimeter accuracy in actual depth readings. Likewise, if you're going up to 6,000 meters water depth, it'd be best to utilize a 6-bar sensor. Just had a question come through here. So the question that's been posed is, I've got an ISD4000 back from the customer, and I don't know how they have configured it. How do I get comms quickly? So this is it's a good question. So usually when we send out sensors, you've got the sensor label there, and that gives you details of the sensor type, the serial number, depth rating, etc. And when it's dispatched from Impact Subsea, we also state the communications on there. So if it's RS232 or RS485, and also the baud rate, it's 9600, etc. But sometimes if it's been out offshore on a customer deployment, and the sensor then comes back to you, and possibly it's reconfigured while it's offshore, and what it says in the label may not actually be how the sensor is configured. So we've introduced a nice, simple way to always get comms. So when you get the sensor back, if you don't know how it's been configured, take the sensor, put it on a desk with the connector pointing upwards, pressure transducer pointing downwards, connect the cable and apply power. And then within the first 10 seconds of applying power, you want to invert the sensor 3 times. So literally just turn it upside down like that 3 times. And it'll default the sensor to RS232 9600 baud and allow you to quickly get communications through a RS232 serial interface. If you don't have a serial interface or RS232 serial interface, if you keep inverting the sensor 6 times within that first 10 seconds from power on window, it'll default to RS485 9600. So you've got a quick way to get it to set into RS232 comms or RS485 comms. And these are both just temporary changes of the communications. As soon as you cycle the power, it will go back to how it's saved. But the reset procedure allows you to get comms, go into the settings, and then reconfigure the sensor to have whatever communications you require. So looking at some of the other questions that we sometimes get asked. One question that sometimes comes up is with regards to the AHRS, so the Attitude and Heading Reference System. So within the ISD4000, you always get pressure, depth, and temperature readings, but you also optionally get Attitude and Heading Reference System. And this will provide you with heading, pitch, and roll. Pitch and roll to within 0.2 degrees, and heading to within ½ degree of magnetic north. So sometimes we get asked about temporary magnetic interference when working around steel structures, for example. How will that affect the heading? So in terms of magnetics, any steel structures, they won't affect the pitch and roll at all, but a prolonged exposure to a magnetic source will affect the heading. And now within the ISD4000, it's got 3 accelerometers, 3 gyroscopes, and 3 magnetometers, one of each in the kind of X, Y, and Z planes. These are all fused together, and an output of that fusion algorithm is heading, pitch, and roll. So the heading is based on magnetic north. So when you first power it up, magnetometers find where north is, and the heading is aligned to that. Then the gyros and the accelerometers help stabilize that heading. So if you have a temporary magnetic interference, maybe you come up close to a pipeline, that'll affect the magnetometers, but the gyroscopes and accelerometers don't register any heading change, so they hold the original heading. If you sit there for a long time, it will slowly drift around, but you have a limited amount of protection from a temporary magnetic interferer. If you require heading, pitch, and roll with a higher level of immunity from magnetic effects, then we have our ISM3D heading, pitch, and roll sensor, which is based on a kind of higher grade accelerometers and gyroscopes, which is worth checking out. Another question we sometimes get asked is, can I run the ISD4000 alongside other sensors? So we provide software called seaView. The latest generation is V3, seaView V3. And within seaView V3, you have an ISD4000 application, which allows you to configure the sensor, calibrate the sensor, view all the data from the sensor, log all the data, etc. It gives you a live platform. So you can either use that as your one display and configuration software, or you can use it just to set the sensor up to output the correct data format to integrate it into a third-party system. If you're running into seaView and you've got the ISD4000 app, you can also run it alongside our other sensors. So you can run the ISA500 altimeter, the ISM3D AHRS sensor, the ISS360 sonar. You can run them all on one screen, all the data coming in live, all the data being logged. So it's one single user interface with a lot of data being shown. Something else which you can do with our sensors is if you run them over RS485 comms, we can do basically multi-drop. So you can run multiple sensors up one single twisted pair, and seaView will automatically interrogate each one and give you the data live in real time. This can be quite useful if you have limited twisted pairs or data channels with sensors to connect over. A quick look, so there's no more questions coming through. I think that's answered most of the kind of common questions we get on the ISD4000. But if you have any more questions at any time, feel free to drop us an email at info@impactsubsea.co.uk or visit our website, where there's a wealth of technical information available there. Bye for now.